Hello everyone, this video is about how to run HFSS and the HFSS. So to begin with, you need to install this software. If your installation is properly done, you should end up with two icons here on the desktop. And if you click on the icons, you will end up with a window, the so-called HFSS windows. So here we go. So to begin with, the very first thing that you need to do is to create a project. So what I would do is I will just click new here, then I will end up with a new project name. And project 4 is the new project that I have created. The next thing that you should do is to convert the gray window here to a design window. So what you need to do is to go to the project tab of the HFSS window and insert HFSS design. So this is the most basic one. And if you do that, you should end up with a three-dimensional you end up with coordinate windows with three-dimensional coordinates. Okay, we are ready now. So the first thing that I would do is to create a substrate. So what you can do is to take a look in this menu, the horizontal menu here. There are many options. One of the options is square. This means you can draw a box here. So I will start from here and then create a large box. Yeah, I don't know the size yet. Now the rectangular box is basically created, but the dimension may not be what we want. So what we are going to do is to change the dimension, and we are going to make it say 10 millimeter by 10 millimeter. The substrate thickness should be 1. So let's say 1 millimeter. So apply, then we will end up with a substrate. And obviously, the names of this box does not have to be box 1. You can change it. To change the name of this box, then you just double click here. And I will change it to substrate. And the material for this substrate should not be vacuum. It should be, say, any material, say F allow 4. So let's do it. Assign material, and I should end up with a window with a lot of options. So I will choose the option for FR4. So this is the one, FR4 epoxy. So basically, I've done my job here. So you can feed all. yeah, click the feed all commands here. Then you can see everything about the structure. The next uh, thing that I'm going to add is the ground plane. So to do that, I'm going to replicate the previous step, but with different dimensions. So again, something like this, yeah. So this is the ground plane. Of course, the ground plane will not be that thick. So first of all, I'm going to change it to another name, say ground. And the material can be assigned. So by entering assign material for this one, I can change to whatever material I like. I believe copper. Copper is the white soil. So I will choose copper. And the size of the dimension, yeah. So I will choose 10, right? And 10, yeah, just exactly the same as the substrate. But the thickness should be 2 microns and it should be pointing downward. So 0.02. Here we go. So this is the substrate, the ground plane. Uh, and also, I want the ground plane to be colored to different to another color, just to make it differentiable. Say I will choose um, blue here, so that the ground plane is now in blue color. Now, the next thing that I need is to add the metal track for the microstrip line. And again, I can use this option again to create a rectangular box. So I just randomly create a rectangular box and then change the size. The size here should be say 4, yeah, 4. Uh, it should be the y should be 0, and z is the height. So it should be on the top of the substrate. The thickness of the substrate is 1 millimeter. So I will just put 1 here, and the width here should be 1.85, which is the width for a 50 ohm microstrip line. The length here, say make it 10. Okay, and the thickness here should be positive 0.02 micron. So that's done. Right? So this is the transmission line I have created. Of course, the color is not right, and also the name. Right, the name should be microstrip, and the color. Let's make it blue. Okay, and assign copper. Assign material should be copper. So okay, so that's done. So now you have a substrate together with a transmission line. So basically, you have done almost everything, but with an exception. You also need to add port 1 and port 2 to this structure in order for it to be simulated. So to do that, what I am going to do is to zoom over part 1 or part 2. I will just use zoom area here and then make a square here. I will make it even further zoom in to it. Now, the next thing that you need to do is to use select, and you choose select edge. This is the trick where you can create a pot more easily in HFSS. And you choose the uppermost edge, which is the top edge of the metal track. So I will do that. So you have already selected the track, the edge. So you, at the same time, you press the control button. And by doing this, you can simultaneously choose another edge. Now, without releasing the control button, I will choose another edge. So the outermost edge, right? Ground edge 66, so 46. Okay. So I left click my mouse, lock quite right. This is not the one I want. I will choose. Yeah, I think it is right now. So I chosen two edge together. And the next thing that you would do is to right click your mouse. Yeah, position your cursor to the design window and right click your mouse. And I would assign excitation and port. And then there are many options. The right option you should choose should be modal num port. So you will end up with a window asking you some questions. The first question they will ask you is the impedance of this port. I will choose 50 ohm, and it will further ask you whether this line should be normalized to the system characteristic impedance. I wouldn't do that because the system is also 50, so there is no more renormalization need. So okay it. So if you do this step correctly, you will end up with a rectangular patch here. This is an indication that the port has been created over this region. If you end up with just an arrow pointing upward or downwards, then something is not quite right. Now, I've created part 1. The next thing that I'm going to do is to create part 2 as well. So first, I will just zoom off, and then I will rotate the design. So now, I'm now I can see the area where part 2 should be. So I will use zoom area to look at the area more closely. So almost right now. Again, I'm going to choose select mode edges. And I will position the cursor right over the leftmost edge. And then left click it. So automatically uh, you select this edge. and then uh, press the control button of your keyboards without releasing the control buttons. Then you position your cursor to the rightmost edge. So rightmost edge, according to what I have here, is ground edge 48. So I just click it. So apparently I got it right. So now release the control button and you can see you have select two edge. Why the one on the leftmost position and the other edge in the rightmost position. So the next thing that you are going to do is to assign excitation and port, and then model long port, and then we are going to go through the similar procedures. 50 ohm, and then I'm not going to be normalize it. So again, if everything is correctly done for the port, for creating the port, then you should end up with a red rectangular patch here. Without this red rectangular patch, right, you most likely uh, have not done this step correctly. Okay, I'm going to fit all. So this is the design. Now, basically, right, almost everything is done. The next thing that I'm going to do is to create a boundary box for this design. To do that, you go to HFSS tab and then create and scroll down to the boundaries option and assign. No. I shouldn't do that. I should stay. I should create a box first. Let's see if I have this option. Apparently lock here. So what I do is I position the cursor in the design window and then right click it. Apparently I got it. I right click my mouse and then I end up with this region. Create open regions. And this option will end me up with a box. And this box is called boundary. This box has nothing to do with the design, but you will create a boundary to calculate the. You create a boundary for calculation of the far field. Now I click here, create open region. So I end up with a window, right? And I will choose radiation. Radiation is where you should use. And then create OK. And you will create a box. And the box can be seen here. Yeah, this is the box. And I can fit all here. Yeah, so this is quite a big box. You don't really need that big. The reason is because the bigger the box, the more simulation time you will need. The more simulation overhead you will end up with. And more importantly, the mesh density will be extremely large. So what I would do is to shrink the size of this patch. So I will click here and create region here. And then I will double click it and then I will just recreate, shrink the size. So what the system has done is they create a padding layer for the X, Y, Z dimension for all the surface. Uh, the padding thickness is 20 millimeter. I don't think we need that much. I think 15 is enough. I will change it to 15. 15, 15, 15. So by doing this, the overall size of the boundary box will be smaller. Yeah, exactly. This is exactly what I want. So now, basically, this is what you need to do. So I'm going to check whether the radiation box has been created. Apparently, we have. I will check boundary here. So apparently, we have done it. So, so this is the design we have. Um, we are ready for simulation. So we click simulations, click on the simulation tabs, and probably we need to fine tune some of the options, some of the settings, say mesh setting. To play safe, I would just choose the cross costs option. I wouldn't choose the middle one. I would choose the worst one to start with, and then I would just okay it. Now, I will simulate this one. I think we are ready. But to do that, we need to specify the frequency range. So to start with, I will use the start frequency 0.1 gigahertz, uh, and the stop frequency I will choose 5 gigahertz, yeah, to make it fast. Yeah. So I will also save the field. This step is very important. If you save the radiated field, then at the end, you will end up with a far field. So I will just create far field here as well. So by doing this, you don't just simulate the transmission lines, the- you don't just simulate the S parameter. You also treat the transmission line as an antenna, and you create a far field out of the transmission line. So I will okay it. Now I think we are ready. I will check whether we have gone through the override procedure. Apparently, uh, we've done. So we will just click this button. Analysis, analysis all. And the system will end you up with a question. They will prompt you to save the design. I will just choose the default one, project 4, which is what I have initially created. Okay, so now it's pretty much done, right? I can show you the progress window, and you can see the progress of simulation. And you can also see the message manager window where you can check uh, if there is any error uh, or any other system message. So you need to wait. I don't anticipate this step will take a long time, but let's see. Apparently, the simulation has been done. So with this in mind, I should end up with all the simulation results. So what I can do is I can check at least, right? I will end up with some simulator S parameter, S11 or S12 or S21. So what you need to do is to click on this option, right? Terminal solution data report, and I will plot the 2D diagram, and I will choose port S11 and S21, and the unit should be dB, and I should end up with a window with the S parameter, exactly what you want. So the green one is S21, as you can see here, and the red one is S11. So this is an indication that The transmission line has been properly created. It is a 50 ohm transmission line. This is the reason why we end up with almost lossless. And the S11 here is also very low. So I think we have done this. But in addition to the S parameter simulation, you can also check whether there is any far field. What we can do is we go back to simulation and then we check out this option, far field report. And you have a number of options. I will choose 3D polar and I will choose directivity. Then I will direction should be direction total and I should choose absolute value. So here we go. And this is the directivity ports for the transmission line. I'm now treating the transmission line as an antenna, and this is the far field. And this makes sense because the transmission line itself should be very similar to a monopole. Isotropic antenna. Okay, so I think this is all we need to do. Okay, by the way, if you need find a mesh, you can also do this. You just click on the simulation window and then click on the option for the best setting. And previously, we have chosen the worst mesh density. I will just move it to fine tune it, yeah, and then I will do it, uh, and then you will just click on simulation. I should again I should be able to get something similar. It takes a little bit longer, but the result should be more accurate. Okay, this is pretty much very straightforward. It takes quite a long time. Let's see. Okay, done so quickly. So result, and then 2D, and then I will check again. So it looks quite good, yeah. The S11 is much lower. It makes sense. Okay, if you have any questions, if you have any further questions, please leave your questions to the comments section of this video. Thank you. Bye-bye.